There's something amiss in the mass of the universe. Everything is not all there is. If current theory is right, the sum of every structure that can be seen is no more than 20% of the total amount of matter that must exist. Visible stuff is made of so-called baryonic particles, the familiar protons, neutrons, and electrons. It's you, your computer, the Earth, the stars. That should be all there is to it.
Certainly we're part of the picture, but in fact, we're really not important parts of the picture. It turns out that most of the matter that's creating the gravity is something else, something we're not familiar with, and has come to be called dark matter.
Stars and gas gyrate, and galaxies swarm in clusters. Measure the velocities and separations, and you can calculate the mass of the dancers. Compare the tally with what you expect from the inventory of known objects, and come up short.
We don't get the mass that's implied by the rotation. Fact is, we don't even come very close. Fact is, we only get about 10% of the way.
As close by as your neighbor galaxy, Andromeda, stars near the rim whiz round nearly 10 times faster than they should. Either gravity doesn't work the way Einstein said it should, or there must be a mysterious form of matter, unobservable matter, dark matter, and a whole lot of it. In rich clusters of galaxies, most of the observed matter is in ionized plasmas that permeate the clusters, emitting X-rays of a spectrum in sync with their temperatures. Temperatures correspond to equilibrium motions. Motions and spatial distribution imply mass, and that cluster mass bends light from sources on the other side. It's called a gravitational lens. The amount of distortion depends on the cluster mass. Observation after observation has shown there's a lot more matter in the clusters than meets the eye. Dark matter. Is there enough dark matter to exceed the so-called critical density? To call the universe to reverse its expansion? To end it all in a big crunch billions of years from now? It seems the answer is no. You'd need 3 to 5 times more of it for gravity to call the cosmos back together. Why does dark matter matter? Because without it, you would not be.
The dark matter was very important as the creator of the gravitational wells that allowed everything we know and love to come into being.
The visible stars and gas in galaxies are but cosmetic frosting collected within these gravitational wells. Without dark matter, gas lacks enough gravity to fight the apparently inevitable cosmological expansion. Without dark matter, your universe would be an uninhabited quasi-vacuum at 2.7 degrees Kelvin, and cooling. A cold and silent hell. But what is this dark matter? It could be made of machos, massive compact halo objects, huge numbers of black holes, brown dwarfs, white dwarfs, or neutron stars, lolling around in the outlying regions of galaxies. The more likely alternative, WIMPs, weakly interacting massive particles, relic particles from the Big Bang, close cousins of neutrinos. In the superhot particle stew of the first second of time, this family burst forth to permeate the universe. But these particles interact with other particles so infrequently that huge numbers could be coursing through your body right now and you would never feel it. Neutrinos themselves are too light and move too fast to make a major contribution to the dark matter inventory. But their heavier cousins, the WIMPs, may hold the key to the so-called missing matter that seems to be necessary for the universe to look the way it does today. If so, the meek may or may not inherit the Earth, but they certainly created it.